In this section, we will talk about how to use similar polygons. What does it mean if we say two polygons are similar? How is that information important to us? So first of all, we call two polygons similar if their corresponding angles are congruent. In this figure, we see that angle L is congruent to angle M. I'm sorry, let's erase that. I mean angle L is congruent to angle P. Angle M is congruent to angle Q. Angle N is congruent to angle R. And angle O is congruent to angle S. So corresponding angles, let's head that. These are corresponding angles in the two quadrilaterals. And to denote that they are similar, the statement that we write is that L, M, N, O is similar to, it's in sideways S, to P, Q, R, S. Note that in this similarity statement, the corresponding angles are in the same position. So L is congruent to P. How do we distinguish between congruent and similar figures? If two figures are congruent, then their corresponding lengths are equal. They are in the ratio of 1 to 1. Whereas if they are similar, they could be in a ratio of 1 to 1, but they could be in another ratio. For example, I could say this is 6, and if this is 4, then the corresponding lengths are in a ratio of 6 to 4. When we have two similar figures, we can write something called a proportionality statement. And a proportionality statement is simply, let's write that down, proportionality statement. And it's simply stating the ratio of two corresponding sides. And one of the ways that you can figure out which sides are corresponding is to figure out which congruent angles they are opposite to. So in this figure, opposite to M is a segment length with length 6, and opposite to Q is segment length 4. So I'm going to write my proportionality statement, and I can also come up with this from the similarity statements. L, M over P, Q equals M, N over Q, R, which is equal to N, O over RS, and let's not forget the first and the last, which is LO over PS. So which two corresponding sides have we been given? LO over PS, which is this last ratio here. And since that is equal to 6 over 4, all the corresponding sides will be in the ratio of 6 to 4, which can be reduced to 3 to 2, by the way. You always reduce a ratio to its lowest length. 6 to 4 is the ratio of corresponding sides, and it is also called the scale factor. So let's just go back and look at this. The scale factor, if two polygons are similar, then the ratio of the lengths of two corresponding sides is called the scale factor. So the scale factor for these two is 6/4, which is equal to 3/2. Another way of writing a ratio is 3:2. And when you convert this to a fraction, the 3 goes in the numerator and the 2 goes in the denominator. Okay, how does this affect the perimeters of two similar polygons? Well, there is a theorem which says that if two polygons are similar, then the ratio of the perimeters is equal to the ratios of their corresponding lengths. So what we are saying is, let's say this is let's say that we know that the perimeter of this polygon is 72, and we want to find the perimeter of the smaller one. So we'll call that PS, and this is PB, which is the bigger one. Well, let's take the same scale factor as before. If this is 6 and this is 4, what we are saying is that the perimeters, so PB over PS is going to be the same as the scale factor, which is 6/4, and PB is 72. We want to find PS, so this is 6/4. Cross multiply, you get 72 times 4 equals 6 PS. Divide by 6 and divide by 6. So that gives us 6 goes 12 times, and we get the perimeter of the smaller one is 48 units. Since we're not given any units, we just say units. Note, it's very interesting that we didn't need to know all the sides. We just needed to know what the scale factor was, which is the ratio of two corresponding sides, and we set it up equal to the perimeter. And this is basically what this is saying. If you look at the top here, that's the perimeter of that polygon, and if you look at the bottom, that is the perimeter of this one, and the ratio of the perimeters is the same as the ratio of the corresponding sides, and the corresponding sides in this case are KN or SP. So these are the ones we were given, which is 6/4. Okay, so we already talked about this. Corresponding lengths in similar polygons. If two polygons are similar, the ratio of any two corresponding sides is equal to the scale factor. So if you are given that the scale factor here, let's just make up a scale factor. Let's say the scale factor here is, and these two are similar, and these are how the angles are congruent. Okay, so let's say you're given that the scale factor is 7:3, and that is going from the bigger one to the smaller one. So if we know that this side is 15, let's say we're given this is 15, what is the length of this corresponding side? So the way we set this up is we have to say, oh, the scale factor is 17/3. That's going from big to small, and that's going to be the question mark. That's what we want to find over 15, and we'll give it a variable name. We'll say 17 over 3 equals L, which is the length of this segment. We'll call it L. L over 15. So if you cross multiply, you get 17 times 15 equals 3L. And if you solve, you'll get, if you divide by 3 and you divide by 3, you get L equals 85. So given the scale factor of two similar figures, you can find corresponding lengths. And just that you know, 3 goes 5 times here. Okay, time for you to do some problems. You are constructing a rectangle area for young children similar to one with length 25 meters and width 15. The new one has a length of 5. What is its width? So what you need to do is go ahead and draw some figures here, and then find the new width. Okay, a couple of more problems. In this particular problem, make sure you may want to mentally redraw these figures or physically redraw these figures so that they are in corresponding positions. Find the corresponding sides. That is, corresponding sides are sides opposite the same angles. And then solve for the side and solve for the angles. Note, and I want to remind you, that the angles will be congruent, whereas the sides will be in the same ratio as two other corresponding sides. So that's my hint for that one. And here you can use the fact that two similar figures have the same scale factor. Look at the theorem above. So good luck, and you'll find the answers in a call out.